Hi everybody! So today we're going to start talking about a slightly new topic for this chapter, which is the idea of having a function. We're going to start today with some basic ideas and try to establish what makes an equation or a graph a function versus not a function. So let's just start with the definition. A function is an equation where every input has exactly one output. So the idea here is that sometimes when you plug numbers into equations, you can get more than one answer. And sometimes when you plug in numbers to equations, you only get one answer. The types of equations where you get exactly one answer and not getting two answers for the same problem are called functions. So characteristics of a function. Well, let's start with an example. An example of a function would be like if I made an XY table, it would be like this: 2, 1, 0, 3, 4, 3. Each of these x's is only matched up with one y value. Now, an example of a not function would look like this. If I made an xy table and I had 2, 1, 2, and then I had 3, 4, 5. In this example, the 2 and the 2 have two different y values that both go with the 2 as an x value. And that's bad. If I have an x of 2, I don't want to have two different options for my y. I want to have one option. So the way that I really usually describe this is like this. Everyone, and by that I mean the x values, can only go to one party at a time. So if 2 is going to 3's party, and 1 is going to 4's party, and 0 is also going to 3's party, that's fine. But 2 cannot go to 3's party and also go to 5's party at the same time. So those are kind of the rules for functions. It's a special type of equation where everybody can only go to one party at a time. Now we have different ways to determine whether we have a function or not based on the given information. So if I give you a table of values and I say, is it a function or not? What you're going to do is match up the x values. Here we have 2 going to 1's party and 2 is going to 4's party. So this would be not a function. Whereas in this table, 2 is going to 1's party, 3 is going to 2's party, and 4 is going to 3's party. Nobody's trying to go to more than one party. So this would be a function. On a graph, we use something called the vertical line test. Because we don't have a list like this, it's a little bit harder to check whether they're going to two different parties or something like that. We would with numbers. So what we do here is we draw vertical lines. If you draw a vertical line anywhere on the graph and that line goes through two dots, see how this line goes through two places of the graph? We would say not a function. Whereas if you can draw vertical lines, and no matter where you draw them, each of those lines only crosses in one spot, that would be a function. So think about this as this line is trying to go to two parties. He's not allowed to do that. Whereas each of these lines is only going to one party. So that's okay. Now, what if I gave you a list of ordered pairs instead of a table? Well, it's kind of the same thing. You just think about how many places they're trying to go to. Here, 2 is going to 1's party, 3 is going to 2's party, 4 is going to 3's party, 2 is going to 5's party. Uh-oh. 2 is trying to go to 1's party and 5's party at the same time. So we would say that this is not a function. Now in the next example, 2 is going to 1's party, 3 is going to 2's party, 4 is going to 3's party, 5 is going to 4's party. Everybody's only going to one party. So for this one, we would say that it is a function. Now the last thing I might do is give you a mapping diagram. It's basically like an XY table, but with arrows drawn between the numbers. In this first example here, 5 is trying to go to 3's party and 4's party. So we would say that that is not a function. In the next example, where everybody is only going to one party, we would say that that is a function. All right, so I believe that that is it for today. Thank you so much for watching. I will see you guys in class tomorrow, and we will practice deciding if we have a function or we don't. See you then.